All right, today we're gonna talk about factored form, specifically how to find key features of factored form, specifically how to find x-intercepts. So before we get into why factored form is really good for finding x-intercepts, I just want to talk about some of the things that make x-intercepts special. So if you have a graph, like a line, something like this, we could see that it crosses the x-axis at one spot right there. That would be considered the x-intercept. Okay, if you had some other kind of graph, maybe you have something like this, where it's a parabola. You can see it crosses the x-axis twice, here and here. Those are your x-intercepts. Okay, if you've got a really crazy graph that goes like this, right, you've got a ton of x-intercepts every time it crosses the x-axis. Now, because x-intercepts have to be on the x-axis, we know already that their y-coordinate must be 0. So all x-intercepts follow this pattern where they have some x value, but the y value is 0. And this has to be the case because if the y value is anything except 0, like if it was 1 or 2, those points would be too high. They wouldn't be on the x-line. And if they were negative, they would be too low. So it has to be 0. And that's what we're going to use. This fact is what we're going to use to help us find x-intercepts. Okay. So factored form. How does that help us find x-intercepts? Let's say we have a factored form of a quadratic equation, something like x plus 3 times x minus 7, something like this. Because we know when we're looking for x-intercepts, we know that the y has to be 0. We can kind of think of this, right? We think of the same equation, but where the y is 0. Right? So the y is not just y, now it's a 0. And we ask ourselves, what values of x, which numbers can we put in, substitute for x, so that we will get this equality to actually be equal? Because of the way that factored form is set up, there's a multiplication that's happening here because of these parentheses like this. So it's kind of like this is multiplying this, right? So you've got something times something equals 0. Now that can only ever happen. You can only ever have a multiplication equal 0 if at least one of these is 0, right? So either x plus 3 has to be 0 or x minus 7 has to be 0. That's called the zero product property. But we can set that up. So either x plus 3 has to be 0 or x minus 7 has to be 0. And if x minus 7 has to be 0, then x could be 7. But if x plus 3 is 0, then x could be negative 3. And so we've got our two x values. And when we write our points, right, so our x-intercepts for this equation, we know already the y's are 0. And we have one where the x is negative 3. Right? So here's our x, here's our y. We already know the y is 0. Our x is negative 3. And one where the x is 7. And that's how you find the x-intercepts from a factored form. We'll do another one real quick. Maybe you have something like y equals 2x minus 7 and one where it equals, and also x plus 1. Right? So the same thing happens. We've got a multiplication and we want it to equal 0. So we can say 2x minus 7 equals 0 or x plus 1 equals 0. This one's real easy. X can just be negative 1. This one's a little more complicated. Here we would have 2x equals 7. We would solve for x here. So 2x would equal 7, and then x would then be 7/2. So in this equation, our x-intercepts would be 7/2, 0, and negative 1, 0.